Okay, we are back with the third and final part of bug, and in this video we're going to be doing the driver, which I'll show you in just a moment. A reminder, I kind of invite you to code along with me. Don't just watch the video, but look at the source code and think you know what is going on. This particular solution is going to have something kind of new at the end, a little technique that you maybe have not seen before. So let's get started. But here I have the final product, right? This is currently running, I can tell because my little stop button is capable of being clicked. But we see our bug in a world. This world has a length of 10, and the bug is in position 0. Okay, then we're presented with this menu. Choose one. We can end the program with a 0. We can do 1 to move, 2 to move a certain number of spots, and 3 to turn. Why don't we just start by moving 1? And there we see that our bug went forward just 1 spot. If I enter 2, I get to tell how many spaces I would like to move. Okay, so I don't know, maybe 4. And we see our bug jumps a good bit. If I turn the bug, we're now facing the other way, and I could turn back if I wanted to. If we manage to move too far, we're going to end up right back where we were. Maybe 10 wasn't a good one because it's just going to put us back all the way around. But if I move, like 6 spaces, that's going to push us off the edge, and we're instead going to wrap around back to the beginning. Okay, so let's get started with this driver. So I'm using scanner just to get input from the user. So we're going to bring in scanner. Why don't I just scrap everything I got and we'll get started. Now the first step to implementing scanner is to import it. But IntelliJ and these big brain IDEs, we can actually kind of jump to step 2, which is creating our scanner. Right? This thing says, hey, there's no scanner, there's no such thing as scanner. Well, we haven't imported it yet. And what I want to show you is that we can hover over this and get possible fixes for this problem by hitting Alt-Enter. In this particular case, IntelliJ can identify the exact problem, which is scanner wasn't imported, and so it is imported as such. In a similar fashion, I'm going to delete this and back it up. If I start typing scanner, the IntelliSense, that's what this is called, where it's kind of auto-detecting what we're typing and offering solutions, notices that, scanner, there's this thing called scanner coming out of java.util. Well, that's what I want. So I can just hit enter, and that will also import it. So we're going to create our scanner object, right? I just breezed past step 1 of implementing scanner, and I'm on step 2, which is constructing my scanner object. This one's going to be called input, and it's a new scanner that reads from system.in. I've told you before, but another popular name for these scanners are KB, indicating that it reads from keyboard. Up to you. So I have my scanner object. Now we're kind of ready to prompt the user, and that's where we just kind of give them a menu. Actually, what I'm ready for is to display my bug. Why don't we go ahead and create our bug? Bug is a new bug. Why don't we give our bug a different name so it's not confusing? We'll create a bug called, I don't know, Larry, and it's a new bug, and we'll do a world of 10 by default. Okay. Future iterations of this program, maybe you actually use scanner to figure out how big the user wants the world to be. I'll let you implement that on your own. So we have our bug. I want to kind of display to the user what it looks like initially. So we're going to use a systemout.println, and we're just going to print off Larry. Recall that what I am doing is implicitly calling the toString method. I'm effectively saying Larry.toString, right? And because Larry is a bug, we are calling bugs toString, which is going to give us the initial world, right? What the bug looks like. The particular constructor that I'm calling is the one that only takes in 1 integer. So if I look back at that, we're effectively doing all of this, where we're initializing the world length based on that integer. We set the bug's position to 0. We indicate that it's facing right, and we use the character that shows that it's facing right. So that's what we're going to be able to see initially, the bug's initial state. Now I'm ready to present the user with the menu. Okay, I'm going to use just several systemout.println. You could use just 1 string and use like new line sequences, right? The \n in order to kind of create just 1 string that displays the menu, but I'm going to say choose 1. And let's see what our menu looks like. We're going to have 0 to end. We're going to have 1 to move. We're going to have 2 to move in being the number of spaces that we would like to move. And lastly, 3 to turn. So it's real nice to give the users a numbered menu option. That way all they got to do is enter numbers in order to navigate this menu. You could, in theory, take in like strings. In the future, we may consider taking in strings where the user could do end or 0. Right? That's going to require some converting to decide if this is a number. You know, we're taking in a string, but did the user actually enter a number? I guess we could just treat it like it is a string, right? The string 0. So here we go. We got our scanner created. We've created our bug. We're looking at the initial state of the bug. The user is then presented with a menu. We are ready to start looping. Okay, think about the loops we know, for loops, while loops, and what should we use here? Okay, a for loop is great when you know the number of iterations, right? You're iterating a certain amount of times based on like some number. Here, the number of times we iterate is kind of up in the air. It's based on user input. And that's when a while loop kind of makes sense. Whenever we don't exactly know how many times we're going to iterate. So I'm going to create a while loop. And what I want you to think about is we're going to keep looping as long as the user doesn't enter a 0. Okay, well, let's get that user input and then we'll check it. So I'm going to create an integer called choice. Right, we're ultimately getting a number from the user. And that's going to be equal to input.nextInt. So we'll take our scanner object, which we created up here, and then we're going to tell it to get the next integer, which I'm then saving into a variable. And once it's in that variable, it's in my program. Okay. My scanner's created way up here. We could create it as laid up here. And in fact, I'm actually going to do that. The reason being is that best practices kind of indicates that we should narrow a variable scope to as small as possible. Right? There's no reason for the scanner to be created up there. It's taking up memory for a few lines of code. That is like a blink of an eye, less than. Not a big deal, but best practices kind of indicates that let's just narrow this scope so it's as little as possible. I really don't need it until this moment. So I'm going to bump it down. So we have gotten the user's choice. I want to check it. While choice does not equal 0, right? 0 is the only one that ends this for me. What we're going to do is process their choice, right? I need to decide, what am I doing here? We're going to use a logic tree here, if statements. If, this is probably the easiest one, right? If the choice is 1, that indicated the user wants to move. So I will tell the bug to move. My bug, in this case, is called Larry. I'm going to take Larry and tell him to move. That's it. Why don't we kind of see what we got here? This may be something we can execute. I'm going to right click in free space and tell it to run. Here we go. This is what we got so far. We see our bug in its initial state, and our menu pops up, choose 1. My program, I can stop it, which means it's running, it's waiting on me. Right? Why don't we move? That's where we're at so far. It's not too terrible. Nothing is being displayed because we have not kind of shown those changes. So why don't we bring that in, right? After we perform the user's action, let's display our bug. That is, I'll do a sout on Larry to see the change. Let's try that again. All right, I'm going to tell it to move. Whoa. Okay, so it's just processing 1 over and over and over again because choice is not changing, right? This is based on what the user has entered. So after I get the user's choice and I decide they want to keep going, and I process their choice and I show the change, I'm ready to get a new choice, right? That effectively means that I want to display this menu again. I'm going to copy and paste this, and if you're cringing, you should be. We're going to come back. That's what I'm going to show you at the end of this, is how we reduce all this duplicate code. I'm going to show you kind of a technique so that this is a lot cleaner. But the thing is, if my loop is going to be based on user input, I got to have user input to work, right? But then here again, I need user input because this loop is still based on user input. So we're going to present them with the menu, and then I'm going to get a new choice. Okay, let's see what we got so far. All right, our choices at this point are basically 0 or 1, and that's okay. We're just testing. I'm going to run it. Choose 1. I want to move. Oh, sweet. So we updated. We moved 1 spot. And it is waiting on us still. Again, my stop button is there. I could maybe move again. Hey, this is not so bad. If we hit 0, the program finishes, right? We exit the loop, and that's the end of the program. Let's bring in our other stuff. Turn is actually probably the next easiest thing to add to our logic branch. So I'm back here in my loop, and we're processing. If the choice is 1, we're going to move. Otherwise, if the choice is 3, we're going to just simply turn. Let's try that. I'm going to run it. Right away, we're given this menu. I can turn him off the bat. All right, I'm going to face him left, and I'm going to move him now, and you can see that he wraps around to the other side. If I turn it and then move, that's kind of cool. Okay, so we just have one choice left to do, and that is this one. The only reason why it's somewhat difficult is that we have to basically get additional input from the user. I'm going to add to this logic tree. Technically, it doesn't matter where it goes, but obviously 1, 2, 3 makes a lot of sense. Else if our choice is 2, okay, well, if we hit this option, we need to get additional input from the user. If I show you the finished product again, right, here is our menu. The user entered 2. We need to then ask, how many spaces would you like to move? And then we're getting that. So if we hit this option, what I need to do is present the user with a prompt. How many spaces would you like to move? And then we need to actually get that. Now, I don't want to save it into choice because that could possibly interfere with what I got going on, and it just doesn't make sense. So let's create a new variable here in this scope called spaces. And that is going to be, I can use the same scanner, however, because it's just getting integers for me, input.nextInt. I'm ready to move that number of spaces. I can just say Larry.move that number of spaces, which is saved in the variable. Let's try this out. I'm going to stop my program. I'm going to tell it to run. And here we are back at the beginning. I want to move in. Here's our prompt. How many spaces would you like to move? Why don't we jump like 4? Oh, that's nice. Another 4. Another 4. That's pretty cool. Okay. Something I kind of will show you it's a little trick, is a little interesting, is that I can actually reduce this a little bit. Just because I am getting this integer, saving it into a variable, and then immediately using that variable, I can actually kind of reduce this in a way that you probably haven't seen before. If I'm not using this variable multiple times, it really doesn't serve a purpose. Why don't we prompt the user, we'll grab their input, and then immediately use it in our move call. Turns out you can do this. I'm going to stop my program, I'm going to run it, and we're going to see the exact same output, right? The exact same effect. No problem. So, just kind of cool. This is pretty much it, except I just want to reduce all this duplicate code. What do I mean? Well, we have this loop that is based on user input, right? In order for it to keep going, I need user input. So we're getting user input inside the loop. That makes sense. But to do the initial iteration, I need user input. So I'm getting user input just one time before the loop. What I end up with is this menu in duplicate spots. I'm using scanner 2 different times to get a value for choice. And it's just messy, okay? Now, in practice, there's something called a do-while loop. I'll just kind of quickly show you that syntax. It looks something like this. Kind of funky. This is not in the AP CSA subreddit. I did it again. Subset, right? You don't have to know this thing, but if you're interested, you could look it up. And what I'm going to show you is how you can simulate a do-while loop just using our existing loop. Okay, so let me get rid of this boy. And what I'm going to do is this technique, we call it a flag loop. The reason being is it uses a variable that we kind of refer to as a flag. Right. I'm going to create this Boolean variable called done, and it indicates if we are done or not. Initially, no, I'm not done. So I'm going to set it to false. Okay, how does this work? Well, I'm going to end up changing the condition of my loop, and I'm going to say while we are not done. Okay, what this allows me to do is to take this stuff and bring it down into my loop, right? I'm going to cut this, it's Control X on Windows, and inside the loop, I'm going to paste that. So let's think about this logic. I create my bug, we see the initial state. We're going to start our loop. I'm going to present them with a menu. Okay, here is our options. We're going to get that, and then we're going to kind of process it. Right? If they enter a 1, we'll move. If they enter a 2, we'll move a certain number of spaces. A 3 will turn. Otherwise, if they enter a 0, which you could say else if, or we could sneakily write this as just simply an else, right? Indicating that if the choice is 0 or anything else, we can just go ahead and handle all the other choices. Again, sneakily, we're not really conveying that to the user. If the choice is 0, we just stop. How do we stop? Well, there's some coding things you could technically break, but based on our loop, you can set done to true. What that's going to do is it's going to set this flag to true, saying that we are done, and then we just let the iteration finish. What that means is I don't need this stuff, right? I don't need to replicate this code, so I'm going to delete that. Let's take a look at our logic. Program begins. We have a bug. We display it to the user. We have our flag, and we'll say while we're not done. So because we're using this flag, this is why this is sometimes called a flag loop. And we're going to present them with this menu, then get input from the user, process their choice, and if they happen to enter a 0 or anything else, we'll set done to true. And notice this is just the last statement of my loop. So if they do enter a 0, we're done. Okay. If they enter something else, right, like a 1, we're going to move. We would skip all this other stuff. Done doesn't change, which means we come back up and we're still not done. So they get presented with the menu all over again. This is basically simulating a do-while loop without actually having to know it. I'm going to run this, but before I do, I'm going to take this scanner out, because as it stands right now, this scanner is actually getting created and destroyed over and over and over again with each iteration. So I'm going to bump it back up outside of my loop. Doesn't really matter where, as long as it's before my loop. We want to narrow the scope as much as possible. Yeah. But let's try this program out. It's going to be the exact same thing. I'm going to tell it to run. We're presented with our option. I'm moving. Oh, sorry. We're missing a display. All right, after we process the user's choice, I'm going to print off Larry to see that change. Let's try this again. We're going to move. Let's move in. 3. Let's turn. Let's move a couple more times. And then maybe I tell it to stop. I'm going to enter any number, really. Any number that's not 1, 2, or 3 will technically get us there. We see the final state of our little bug, and that's perfectly fine. You could conversely do this as kind of like the very first statement, right? The only reason why I would consider this is if you, right, this is effectively a duplicate. And so if you don't want that, if you do, you're fine, leave it. If you don't want that, you could bump this up, right? The very first thing we're going to do is look at that. What that actually means is I don't need this statement anymore, because on our initial run of the loop, we're going to see the initial state of what Larry is. I'm going to run this again. There is our initial state generated by this SOP. I'm going to tell it to move, tell it to turn. I enter a 0, and we're done. And we don't have that last statement. So this is a cool technique. I actually am quite fond of this loop because you end up getting a lot of control. But the idea is we're going to create our bug. We have our scanner. We got our flag loop. We'll see the initial state on this very first run through, as well as the menu. We'll get the user's input, their choice. We'll process that choice. If it's a 1, 2, or 3, we're going to come back up and have another iteration where we'll see the change that is caused by their 1, 2, or 3 option here on the next iteration. We then get a new menu. We're going to get their choice again, and we'll process the choice again. So as long as they're entering 1, 2, or 3, we're going to keep going. The moment that they give me a 0 or technically anything else, we'll set done to true. And so this loop reads, while not true, aka false. That would be our last iteration, and we would finish. So this is called a flag loop because we're using this little flag variable. It's a cool technique. It gives you a lot of control. I like it. Hopefully you see kind of the point of a driver, right? If anything, this is what this class is doing is very different from what bug is doing, right? Bug is a template. Driver is more of the program, right? This is the actual thing that is executing it. And as I said kind of at the beginning, you could maybe get this value from the user if you wanted to. We could simply change it here. Maybe I have a very large world and my bug is maybe somewhere 10 positions deep. And you can play with it from there. That's going to do it for this one. I'll see you in the next one.